Okay, let's look at the first problem. In the first problem, you're given the following triangle. So you have triangle PAQ. You need to find AQ to the nearest tenth. So I see that I have angle P is 31.2 degrees. Angle Q is 68.5 degrees. And PQ, or psi A, is 1,000 meters. So if I were to do the law of sines, the easiest thing to do, the setup would be angle P with psi P and angle Q with psi Q. However, I'm given psi A. But if I'm given psi A, then I would need to work with angle A. So at this point, I ask myself, or if I remember to myself, that in any triangle, all three angles must add up to 180. So by adding these two together and subtracting from 180, I got that angle A is 80.3 degrees. So now that I've got angle A, psi A, angle P, and psi P, I'm ready to go ahead and do my law of sines. So step 1, write a proportion of corresponding sides to angles. So again, psi P over the sine of angle of 31.2 degrees is equal to 1,000 over the sine of 80.3 degrees. I then cross multiply and solve for P. So sine of 80.3 degrees times P equals to 1,000 times the sine of 31.2 degrees. So now I'm just solving for P, dividing by sine of 80.3 degrees on both sides, and I end up with 525.5 meters. So now if I go back to my triangle for a second, and let me move this guy up here, I wanted to make sense that the 525.5 over here is going to be smaller than the 1,000 because the angle that is facing 31.2 is less than the 80.3, which faces the 1,000. So go ahead and get this down before you go on to the next problem. Okay, just give me a chance to get that one down. All right, so let's go to the second problem. All right, so now I want to do this. Let's try to make it a little bit more manageable. For triangle HJK, measure of angle H is 105 degrees, measure of angle J is 40, and J is 13. So I am not provided with a triangle, but I am going to draw myself one. So I put in angle J is 40 degrees. Side J right across is 13. Measure of angle H is 105. And I'm looking for side JK, which happens to be side H. So if you look at the way this is set up, I have an angle and its opposite side, an angle and its opposite side. So this is actually a perfect setup for the law of sines. So my setup is H over sine of 105 degrees is equal to 13 over the sine of 40 degrees. So I just do the math, and I'm going to get that If I cross multiply, I have h is equal to 13 times sine of 105 degrees divided by the sine of 40 degrees. And when I put all of this into my calculator, what I'm going to get is that h is equal to 20. And again, I want this to make sense, that h is 20. H is opposite the largest angle, so it makes sense that it's going to be bigger than the side facing the 40-degree angle. So go ahead, when you're done with this one, to click out and go ahead and go into slide 3. So let me go ahead and get this out now. So this is aim 20, slide 2 of 4. Go ahead and go into